We are going to kick off with a few demonstrations and discussions around implementing different software tools and features within the architecture to try to give you a little bit of a peek of, I think we'll start with the most polished in what we have in the contributions of Odysseus with Arachne, and then we'll back off a little bit to some raw stuff, but at least will allow me to say that we did include some element of code and lower level feature functionality visibility than what we started off with. I did get 2 requests during the break. One was to try and provide some visibility to what the the Achilles reports look like. So they are actually embedded within the Arachne tool. So Greg will be able to show what those data sources look like. The other question was whether or not we'll have any discussion on security, and we do have a talking point around security later on, thanks to Lee asking to put it in yesterday, and thanks to community people for suggesting and confirming that Lee was once again right. That seems to be a trend. Without anything further, I'll turn things over to Greg to give us a demo of the Arachne platform.
So I'm Greg Klebanov. I'm the CTO for Odysseus Data Services. It's a fairly young niche company, quite established actually in that industry. We're 2 years into a journey, and we develop software for observational research. Louder, okay. We develop software for to conduct observational research, as well as we provide consulting services to enable companies with data. Essentially, we call them ETL or vocabulary services. So today I'll speak about the latest and greatest tool, the latest contribution into OHDSI community called Arachne. Arachne, again, is also an idea that came from that OHDSI community. And the idea was essentially, how do you enable community to conduct scalable, reproducible observational research, not only within a single organization, but across multiple organizations. And Arachne was built with the idea of a federated network study from the ground up. So Arachne is focused on enabling a process that people typically follow when they conduct observational research. And you see here on the slide deck that process. When you initiate a new study, a researcher or a study lead typically creates some kind of a hypothesis, some kind of a protocol. Then they look for people, they look for data, then they execute a number of analysis in a very iterative fashion. They annotate results, and they publish study papers. So Arachne as a solution is built to enable that process end to end. And of course, when we started working on Arachne, we did realize that we do have quite a few tools in that space today, in the space of analysis design. And one of them is Atlas/Web API. It's a fantastic tool where you can design quite flexible cohorts. When you create, you can design and create analytical code, population level effect estimation. Latest tool allows you to do patient level predictions. So we obviously did not want to recreate the same type of functionality. We didn't want to duplicate the effort. Instead, what we wanted to do is focus on integration with tools like that. So what you will see in Arachne is that we've been able to essentially integrate with a number of OHDSI tools, including Atlas through Web API, as well as we also heavily using tools such as Achilles and analytical packages that have been developed by the community, specifically population level effect estimation. So Arachne, again, is 2 different flavors of Arachne. Arachne can be deployed inside a single organization, so you can enable observational research within a single team or across multiple teams, multiple departments in a single organization. That's the deployment when you typically see when you deploy it behind the firewall. There is a second flavor of Arachne, and that's what you will see today. It's actually arachne.ohdsi.org, is when you conduct federated observational studies, meaning you conduct it across multiple organizations, not a single organization, across multiple organizations and data sets that sit behind an organizational firewall. So from a process perspective, they're actually quite similar. from, of course, an execution perspective, those are quite different types of approaches that we needed to take. You see here on the slide deck right now is some key features that Arachne implements. Specifically, we support full study lifecycle management. We've implemented the data catalog, which I think is a great component by itself. So you cannot really enable federated research across multiple organizations until or unless you have a place where you can go and see what data is available. And that's data catalog is where we take in utilizing Achilles reports quite significantly. We have an expert finder, which is really cool, unique component by itself. So what is an expert finder? Again, all of you is part of a community. So when you're beginning to conduct observational research, a lead investigator who initiates a study can go and look up people who will be invited to participate in the study by this lead investigator. So that we call it expert finder. And then, of course, Arachne is built to conduct research, meaning it's built to execute queries, and execute it in such way that you can execute it remotely. That's the best thing about Arachne. So in Arachne, there is a notion of analysis that you can set up. You can execute cohorts. You can execute even more complicated analytical queries. Specifically, we support the out-of-the-box integration with Web API, where you can, and I'll show it to you in a second, import population level effect estimation and submit this code to multiple data sets all at the same time. So that's the idea. And of course, we support today SQL and R, which are one of the primarily languages that are being used in OHDSI. And in the future release, we're also looking into adding support for Python and whatever else community will come up with. As I mentioned before, we did focus on ensuring that we take advantage of OHDSI tools and components already available. So we, right from the beginning, we wanted to utilize what's already available. And we utilized, again, Achilles. We created integration with Atlas, and again, taken we're also utilizing quite extensively R packages created by people like Martin and Peter and others. And of course, the key, the blood vessel of this whole platform, of course, OMAP CDM support. Now, can you run queries without OMAP CDM? Yes, you can, right? Can you run queries in a consistent, reproducible fashion across multiple data sets without OMAP CDM? The answer is no, so because there's so many different variations. What OMAP CDM enables you to do is to design your query once, and then fire up your query to multiple data sources, and then get analytical results back. That's the beauty of, again, OMAP support in Arachne. From a technical architecture, just think about it in such a way that, it will refresh in a second. Arachne has a notion of Arachne Central. That's where a researcher or study teams will come to, and that's where essentially they'll conduct research. So that's where you see a definition of a study. People will define and upload protocols, invite people, check the data catalog, invite or request access to different data sets, and start executing studies. So that's Arachne Central. But there is a secret sauce behind Arachne. It's called data node. So data node, in a nutshell, just think about it as, I'm an old school guy, as an ODBC manager, where you essentially deploy data node into an organization, and you enable data sets to be connected through a data node as a component and then exposed to Arachne Central to take advantage of. And data node, again, it also allows you to manage data set metadata, and that's where you would be able to essentially generate Achilles statistics from. So I know that, go ahead.
I was just curious, with Arachne Central, is that per organization, or is it just one Arachne Central for the whole network?
It's a great question. So it's as many as you want. It could be per organization, or we would like to think about it as a network of networks. So you might deploy Arachne internally, right? So you have an internal network where you have a single Arachne Central and data nodes that you enable internally. Or for example, arachne.rdc.org is Arachne Central utilized by RDC community, right? And you can imagine many more Arachne networks that people could connect to. So the eventual vision that we have is that it's going to be a network of networks connected together to enable observational research, not only within a single community, but across multiple communities.
Just a quick thought, so can they talk to each other? Iraqi Central, can they talk?
That's the vision. So, the idea is that they'll be able to communicate with each other and be able to expose people and data set level information across multiple networks. They didn't talk to each other yet. So on data node side, that's an interesting one. So just think about it. So we have multiple organizations in the single Arachne Central for Odyssey. And you can imagine that there could be multiple data nodes that you deploy into each of those organizations. There could be an organization at Jensen, Columbia, Stanford, and each of them will host a data node, and they might set up their internal data sets to be exposed through data node, and data node will be responsible essentially not only for registering this information in Arachne Central, so they'll show up in the data catalog, but also for any communication that might need to happen between those organizations. In Arachne Central, Arachne data node, the idea is that each of those organizations might have some sort of a design tool deployed. So let's talk about Atlas/Web API, right? So let's say Jensen or Columbia, they all have their own instance of Atlas deployed internally. And the idea is that through Arachne data node, you can now start sharing designs that were created in a specific organization, cohorts, analysis with the rest of the team that participates in the study. So not only you can share designs, but you can import those designs from that specific data node and submit it for execution across multiple data nodes in the network. So it's really, again, the platform was built to enable federated collaborative environment. On the technology side, I'm listing all of those really geeky names, which probably most of you can understand, I hope. But again, it's the latest and greatest. So we've taken advantage of React as a UI framework, and you'll see it in a second. And the rest of the tool set looks quite actually standard at this point. So we use Java, Spring Hibernate. We use Postgres internally to store data. Again, Solr. We use Solr quite a bit to index data in study, for example, studies data, people or data sets in data catalog or expert finder. What else is interesting? We're utilizing d3.js, open source component, fantastic tool. And it's also been utilized in Achilles. And again, you'll see it in a second. And of course, we take and actually have advantage of Docker as a technology to deploy this platform to different clients. So any questions so far? Feel free to just interrupt me and ask questions. Okay, so with that said, let me give you a quick demo. So what I'm going to show you today, again, is Arachne Central as a platform. And again, you can actually see it for yourself. If you go to arachne.rdc.org, you can create an account and log in. But I'll give you a little secret, and that's actually related to the question that myself, Lee, and Frank talked about yesterday, security, right? I think we're all tired of having multiple accounts, right? And we need to create accounts in every single system. So with Arachne, what we did, our company is responsible for that tool called Athena. So if you registered in Athena, you already have an account that you can use to log into Arachne. So we made sure that those tools essentially take advantage of a single sign-on concept. So you can, as soon as you log in into Athena, your account will show up here in Experts Finder in Arachne Central for IDC. So you already registered. And in a future session today, we'll also speak about can we utilize the same approach across all of the platforms that are being used by RSC community, especially in that platform that we'll set up so that people can be consistent in terms of their user information across multiple tools. So Atlas, for example. So we have 2 instances of Atlas set up for that specific demo, because I think it's an important part of the demonstration is to show you how we can, in fact, integrate multiple tools together and take advantage of Web API as a concept, as a technology. So I know Lee is very passionate about microservices and service-based architecture. I know Frank is very passionate about the Web API, and that's a really great example when we speak about integration. We think about it one level above a UI as a framework, right? Just think about business meaningful services. So I've created this examples here. So for example, I'll show you an example of how you can import a cohort from RSC Atlas, or we set up an example or internal Atlas that also has a number of cohorts created that I can use as a demo. Okay, so of course, Arachne, you need to log in. That was actually a mistake. I logged out. And as soon as you create an account, you will see a page like that. So in my previous slide, I told you about multiple components that are available in Arachne. Again, one of them is a study notebook. That's where researchers manage their studies. So what you see here is a list of studies where this specific researcher participates in. A second component is an expert finder. So if I look for Frank, I can find multiple Franks, and here's Frank DeFalco. There's no picture here for some reason. If I want to find a data set, and I set up some examples, and it's synthetic data for obvious reasons, I can look at what data sets available in Arachne, and I can also see custom created metadata. Again, it's a demo website, please treat it like that. As well as if I want to see any specifics, I can open it, and I can see Achilles-based reports. Again, another great example of component reuse and integration with different RSC components. So I can see reports here, and the most amazing part is that if I go to Atlas, and I'll use Community Atlas, I can go here to data sources, I can select it, and I can get exactly the same reports, but in the local instance of Atlas. Right? So again, local instances versus instances exposed to a broader team or a broader community where you can see exactly the same information. So, and Frank, I know you cannot automatically kick off Achilles yet from your environment, but we can. So Arachne data node, actually, we implemented a feature that allows you to click a button and kick off Achilles, and it will generate reports. So since we committed this, you can now implement it in Atlas as well.
How does it tell you when it's finished?
It will enable this button again. So if it's running, the button is disabled. When it's finished, it will say run again, and it will tell you the last updated timestamp. It does. It's a large. Typically, if it's a large data set, it will take an hour. I'm sorry, some hours to execute. Okay, so going back to Arachne. And the last component, but not the least, which is a really interesting concept, and it actually does exist in real world, right? Once you've finished your study, what you want to typically do as a researcher, you want to document it as an insight, we call it insights, and publish it in some kind of insights library alongside with the paper as an outcome of that study. So as you can see here in Arachne, this portal allows you to actually, right from the study, publish an insight alongside with key study information, and today it allows you to attach a paper to it as well. So anybody in the future can go back to that insights library and search for that information. Again, if you are a part of a team and this insight is marked as private, but you're part of a team, you can find it. If it's public, anybody can see it. And of course, in RSC community, we always talk about open studies, public studies. Right? So if I go back to the study notebook again, I got this really cool interface that Pavel Here's the guy on the left side implemented. He's one of the probably best UI developers I've ever worked with. But it allows you to navigate those studies in many different ways, which is great. And again, all studies can be of certain types. Studies can have a certain life cycle status. Studies can be private or public. So why are we talking about private studies? We're talking about OHDSI, right? And it's actually a great question, because another disclaimer I have to make, since we're a commercial organization at Odysseus, right? So Arachne is our product. So there are two versions: community version, published as an open source, and enterprise version. And enterprise version is essentially, if you think about it, it's more scalable integration with your enterprise level systems, and more automated. So that's what we give an enterprise version. But again, community version is fully functional, and the code is committed into OHDSI GitHub. So going back to that question, why would you have private, public studies in OHDSI community if you're conducting open studies? Going back to the discussion we're going to have later today is about having a production environment, meaning that anybody can go right now and just create a study here, and the study will just show up on everybody's desktop, and probably 5 days later, if you like this tool will be crowded with some test studies, some examples and junk, that probably doesn't have any value for community, but might have some value for you if you're learning the tool, right? So what we've discussed is that private and public flag will allow us to first design a study, invite people, design a study, make sure that it's ready to be opened up to the public to see, and then maybe have some kind of a governance process in place. When you say public, it's visible to the community, but it's a clean version of a study, not some test case that I've created for myself. And again, we'll talk about later today setting up for OHDSI as a community to enable, again, observational research across multiple organizations, production environment, and a demo environment where everybody can come and play with different tools. So what I'm going to show you today, again, is an example of a study. And I can talk about it because it's actually an open study that, if you were on the first day of the symposium, you saw a poster that was presented by Aaron Glasnick from Takeda. And the study was focused on non-small cell lung cancer, essentially, patients and their prediction of non-response in patients like that. So, Aaron created a study objective that he then documented in Arachne, attached the study protocol, invited different people or organizations to participate. It's a real study. To participate, invited data sources. Again, those data sources are actually not real, they're virtual, and I'll tell you why in a second. And then we've created an analytical code. So here's an example of a cohort, and Frank and we invented out of a blue moon this extension called OHDSI.SQL. OHDSI, as Frank likes to say it. So you will see, if you open this code, then you'll see it's a template, essentially. OHDSI. Do I pronounce it properly, Frank? OHDSI. Yeah, sorry for my accent. OHDSI, right. So you'll see it's in this format. And then you can, of course, download it, modify it, etc. And more complicated, actually, in this specific case, it's a patient-level prediction study, right? So,
that cohort, was that in SQL or was that in?
It's in this. No, it's OHDSI. So it's a template that is platform independent. In reality, it's a flavor, and Frank, correct me if I'm wrong, it's a flavor of Microsoft SQL Server language, SQL, T-SQL, essentially.
Yeah, so to be clear, what they're doing with Arachne is they talk to the web API, and they are able to get the JSON specification from the cohort, but then they could also use the web API to convert it from the JSON specification of a cohort definition to the SQL that can be used to actually generate that cohort. And that SQL we call OHDSI, which is essentially a T-SQL format with some parameters and tokens inside of it. So they're pulling that back and able to pull from the web API the OHDSI version, which they then could render into whichever dialect, as you're seeing here, for the specific platform that your CDM data sits in.
Yeah, and to do it, we actually take advantage of yet another Arachne and OHDSI component. There are two components. To run code, we use, there's a component called Arachne Execution Engine. And what it does in the backside, it just basically deploys a ready-to-go R environment with pre-configured OHDSI packages. And one of them is SQL renderer. So it takes this OHDSI SQL, runs it through a SQL renderer, and depending on a database type that is set up in the specific data node instance, it will come back with a translation that is specific to this database. It's really cool. Okay, so again, I know there's a delay. So here you see again, going back to, that's a study page, right? What you see here is permissions. It's a private, public study, meaning who can see it. If you say it to be private, then only people within this team can see it. If you say it's a public study, then anybody in the community will be able to see it. There is a study type, and it's configurable for obvious reasons. There is study status, right? And the status does have some meaning to it in terms of that if status is completed, now you can start publishing paper, for as an example, right? Or before you start conducting a study, before you make it active, please upload a study protocol at minimum, as an example. Invite some people, add some data sources, things like that. So it kind of drives you to do what's necessary. And then, of course, here you also see activity that people are, so I was very active in the study, activity that people taken in a specific study. And again, going back to that example, a different type of an analysis is more complicated. In this specific case, our code, patient level prediction. So that's again, real example of real study. Now, another really cool feature, and I'm going to go to a demo study because I want to show you something actually being executed. So demo study is my kind of junkyard which I use for testing. And so again, I will show you an example where I can add a new analysis called OHDSI Symposium test cohort demo. Say it's a cohort type, and I say create. And then if I want to then add a cohort to that specific analysis type, right, I have multiple options. I can upload it as a file. I can point to a link, or better yet, I can import it, right? So in this specific case, this data, this study has been given permission to work against the data set located in, let's say, OHDSI organization, right? And I'm going to click OHDSI, and it's going to reach out to OHDSI web API, but going through a data node. So it's not a direct web API call because we deploy data nodes, behind the firewall. And once it reaches out to this web API, I got all the cohorts that also are available here. So if I search, for example, for Nexium, right? So here's the cohort. So that's the Nexium cohort. So let's say I'm interested in Nexium. I'm going to go back here, click import, boom. And it will import that cohort, again, an OHDSI SQL API, and now I can use it from Arachne to submit to different data nodes. So instead of copying and pasting code that is platform specific, right? I just imported the platform independent code. Now I can submit it, and it's going to be translated by SQL render, and you get results back. So that's an example of how you can take advantage of web API and open source, essentially, technologies. So let's say if I go back and show you a more complicated example. So I say Symposium. Population level effect estimation demo. But in this specific case, I'll say population level effect estimation demo. So Arachne, we create some templated files right from the start. So people know if you want to add custom code, then follow some basic rules of how you don't hardcode your connections, right? Use system level variables as an example, right? Stuff like that. But let's say if I want to import my study from from an existing instance of Atlas, I follow the same steps. I follow the same steps. I point to OHDSI. But since I specified population level effect estimation as my type of analysis, it will ask Web APIs, what do you have in that space? And hopefully, in just about a second, it will give me a choice of different analysis to. That's what I was praying. Yeah, of course, Arachne is very stable.
My fault.
But I got you here. So, and I can choose one of the existing, let's say, this analysis types to import. But in this specific case, it will hopefully, in a second, do something even more interesting. Instead of getting a single module from Web API, a single R module, it got the whole package and even more. It imported a definition of that analysis in JSON. It imported 3 different cohorts that are being utilized. And then what it did, it added a packrat package. So that now instead of having a single R module and risking that, when you send it to the organization, they might not have a firewall access or a network router enabled, and it will not be able to download necessary OHDSI package. So packaged into the same packrat package and self-contained. So now you can send it, and you don't have to resolve any dependencies. So it's a true way of packaging things that need to be executed across multiple organizations and have the same reproducible, consistent study to be executed. And of course here, once I've got this, I can then submit it to different data sets that I already have added to my study. So I got permissions from those data owners, right? And I can select all of them or some of them and submit it for execution. So that's the idea, right? As soon as I submit it for execution, the magic will happen. And so, so that's, again, Arachne in I know it's going to submit it in a second. Arachne in a nutshell. So again, so as you can see, I submitted this package for execution to how many? 7 different or 6 different, 5 different data sources. And they could be located within the same organization, could be located across multiple organizational units. Any questions?
So Arachne was really 2 pieces. Do I have to have like a server at each?
A data node, right?
A data node at each data node. I'd have to have a.
Mm-hmm.
And then, is it like yes or no? Because we see something similar to this with people that have a PCORNet thing, and there are places where they have to stop, they have to review the code before they'll let you run it.
Yeah, yeah.
And so kind of sort of park it, get to the point. Oh, I can read over the code. Yes, I'll run it, but I still want to look at the results before I release it because I have too few people. I don't want to let it out, and those types of things. That's what we see for people.
No, it's a great question. It's an absolutely fantastic question. So, yeah, it's very common, this approval process, because nobody likes, even if you grant somebody permission to data set, you all of a sudden just say, I just run whatever you want on top of my data. It doesn't work like that, right? So the data is very precious. So, and again, I'm going to make a disclaimer. It's an important one. So 2 different versions, community and enterprise, right? So I'll say what's in community today. Because we're enabling observational research across multiple sites that, again, it's a brand new process in community, right? So the way it's done today, you typically design R code, probably submit it, if you go, you put it into GitHub, you send somebody a link, and people take it, run it, dependencies hopefully resolve, and hopefully then you get results, and then you're probably going to send it back through some mechanism, email or whatever, right? So that's manual mode, right? So what we realize is that another thing is that a lot of organizations, for obvious reasons, and I spent many years in the pharma space and together with Lee. So he knows, I know that IT departments don't like opening up firewall for some software to start, sending data back and forth, right? So for that reason, Community Edition, it's enabled with what we call a manual execution mode, right? So you're sending files, data owners will get notified about those files or studies coming to them. They download it, they review it, they run it, they capture analytical results back, and they upload it back to Arachne and share it with everybody, right? So it's clean, it's Apple, it's clean, it's secure, and everybody is happy, right? For those who are more on, let's say, again, a shameless plug, as Frank calls it, in commercial Arachne, there is more in terms of automation enabled, right? So for automated studies, you could, for example, imagine this approval process. I don't want to run it myself, but I want to see what I'm running. So you can look at it, review it, approve it or reject it, run it, review results, approve it or reject it. And of course, for those very simple use cases, let's say if you're working with synthetic data, or you have a complete trust in that team, you can enable full automation, right? But again, we're talking about Community Edition today, and we're focusing on improving and making existing network studies not only better, but even possible. Because Patrick said many, many times, it's reproducible research, it's transparent research, and using emails is hardly a way to, we'll say, do it today, right? It's a fantastic question.
The other question was, because you copied the cohort, now you that much cohort, you're doing versioning, you brought it into Arachne Central, and oh, guess what? These people tweaked it down here, and it's got the same name.
Yeah, so, and that's part of community, as soon as it comes back. Say I did an ibuprofen, right? Here is version 1, right? So I can come here and change it, which is not advisable, but unless you uploaded your code, right? Or I can come here and just refresh it. So what it's going to do is, if Web API is up and running, it's going to go and get the latest version and show you a different version of that cohort now available. As you can see it here, version 2. Can you see it? Oh, now you see it. Version 2 now available, but essentially what I did is clicked here for you. So yes, it does preserve a link. And that's, I forget, I think it was you who asked the question about protocols, or maybe somebody else. Yeah, protocols and how we design our interfaces and how we, essentially outline our object models and things like that. So we essentially, to integrate with Atlas or any other tool, right, or Web API, to be precise, right, you need to know the signature of a web service. You need to know the payload. You need to understand the structure that's coming back to you, right? And again, Arachne, an interesting part about Arachne, just think about a concept. You could, in fact, take any other cohort builder tool that you have deployed in your specific organization, right? And if it does implement the same consistent API, you can point Arachne to any one of them. It doesn't really care what's behind it. It just will work. It will interrogate it, get cohorts. Okay, and again, cohorts will come in the same consistent standard definition, and then it's possible to execute. So that's the idea that we're going to talk about today, or we will talk about it today. How do you define this standard, RSC standard protocol that different vendors that implement cohort builders or more complicated analysis design vendors can implement, and now you don't have this nightmare of trying to figure out if I have this, but I don't have this, how it's going to work together, right? So that's the idea, that's the concept. Any other questions?
So if you create a new account, do I have to send request to the owner of the cohort or study?
Yeah, so,
But I just read it and I don't see what you are showing on the screen. My screen is blank.
yeah, so if you just created a new study, right, again, upload your protocol, invite people. So people is different from a data set, right? People will be, I can invite Lee to help me out to run the study, or Frank. Then it gets more interesting when I get to data sources, right? That's where I add data sources, right? And data sources can be here in data catalog. Those are pre-built examples that we.
So you have to give access to the user.
Yeah. So each data source is connected to a data node, and each data node has a data owner that will get a request and can approve it or reject it. And the request is going to look something like this. Yeah. So somebody invited me to collaborate on a study, I can decline, right? As a data set owner, if I approve it, then it says approved. However, in many cases, you could say decline, right? Another way, again, not every single organization will have a data set registered here because it takes time to deploy a new piece of software, especially if the organization is strict in compliance and what have you. So, but you want to execute something fast, and what do you need to do for this? You just want to share code in the same consistent way and fashion. So for that specific reason, you can come here and create what we call a virtual data source. You come here and say a data source, create a virtual and call it Lee Evans data source, Frank's data source, and say, okay, and make Lee or Frank a data source owner. So they'll get a request that you're sending them some code to execute, and when they execute it, attach results back, it will show us it came from one of them. So they become those virtual data sets that you can execute. But of course, you're going to be missing out any additional features. As you see here is a dashboard coming from Achilles, so you cannot really see what that is. Right? So that's an advantage of you setting up a proper data node and exposing that data set to Arachne Central.
But if we were a data source, would it be like, oh, I'm going to really send you the protocol, sort of the way it's happening now?
Exactly.
I'll send it to you in email, you run it, you give it back, and then...
Yeah, except that it's not lost in emails, and then if somebody leaves an organization that it's lost forever. Not in Big Pharma, it's saved forever. But let's say, in reality, you will never find this again, right? But if it's here, there's a full traceability between, hey, here's my hypothesis, here's my protocol, here's who I invited and who did work, here's my data sources, here's the code that I submitted, here's the results I've got. And don't forget that eventually, after all of this, right, I can go back to that study. Open that specific execution, click, and I can start annotating data. So I can create new annotations saying, I see something very unique about that specific result set. Say submit, right? So people can start collaboratively looking at results that you've received and actually making sense out of it. So that's another important point. What else is interesting?
That brings up now, which is repository, how secure is this? Is it easy to back this up? This has all the information about all the studies that are running. Now it's really valuable.
Exactly. So, and of course, those questions are closely related to how you set up your infrastructure, how you manage your infrastructure, how you back up your infrastructure, some kind of, some more typical of a production-grade environment type of question. So the tool itself, or platform, as I call it, is built to be secure, right? So we have end-to-end encryption in transit or at rest. But as you know, if my web service server is not set up to use to take advantage of HTTPS and SSL, right? There's only so much I can do, of course, with OHDSI, and we're going to talk about it later today. If we're serious about conducting, and we're serious about it, conducting a federated observational research, we are planning to set up a production-grade infrastructure with, all the proper security mechanisms put in place, as well as more kind of production mechanisms such as archiving and backups and things like that, because you don't want to lose this data. Any other questions? Thanks, guys. Thank you.